Hello everyone, this is Mohammed and today is our second live session of DevOps Zero to Hero, and this is May 10th and we are still in the confinement period in 2020. I will start this session by opening the kind of a QA session about the previous live. So if you guys have any questions, please ask it now. Otherwise, I will move on to what I was planning to present today. Any questions about Go that we saw last week? Did anybody get any issues implementing the code or doing the homework? All right, if there are no questions, I will move on. So just for your information in the platform, I added this live session. It has the recording from the previous meeting. So if you missed the previous one, just go ahead and give it a chance and come back with your questions. So last week we did some basic Go programming to learn how to write Go code. And this is a part of the whole kind of DevOps story, where we want to start by developing some code, then deploying it, then managing it. So we cover the life cycle of a DevOps engineer, which is developing, deploying, managing, and operating the software. So today, my objective is to do a little bit of REST interfaces. It's going to be in Go as the last time, and I will continue on the same use case that we started last session, which is a shopping cart, where we will be able to add, remove items and list the items in the cart. Is pretty simple use case, but we will use it as a running example. Then the second objective is, after writing our REST application, I want to build first Docker container that will host it, and we should be able to run it and run some queries on it. All right, so in the platform here, we can jump directly to the REST part. So just one note is that I'm skipping the test-driven development units, and I will go back to show them and discuss them later on in the course when we talk about the CI/CD. But now I wanted to make sure that everybody is happy with what you are expecting, and I wanted to jump directly to the REST part. So let's do that. What is REST? So REST is kind of a representational state transfer protocol that allows to describe resources and how to pass a resource from one state to another using HTTP query. Historically, REST was developed by someone during his PhD thesis, and you can Google that. This guy is Roy Fielding. He did that in 2000. REST is kind of a very good simplification of client-server communication. So if you have any client that you want to set it to communicate with the server, a nice way and organized way is to define the server components as resources, and then you start to send REST queries to change the state of these resources by creating the resource, deleting the resource, updating, patching, and using these HTTP REST calls. One basic kind of idea behind REST is that it is stateless, which means that when you execute different queries, like the platform is not really safeguarding or storing any state for these queries. So it doesn't really understand that this one came after the other, or doesn't maintain any state regarding this order. Okay, so why it is named REST? Because it is for resources and their state management. And whenever you decide to make a change to the state of a resource, you need to send the right HTTP query. There are different queries designed for that, like the get, to get the information as its name, as the name says. Post is to create a new resource. Put is to update a resource. Patch is to modify also a resource, and delete is to delete the resource. There are some discussions in the community about the usage of post and put, because some people use them interchangeably. So there is no harm for using post to update as well. But this is how it was defined in the beginning, and this is like the common way of using them. I will jump directly to write the code to do some REST, because I believe like doing the thing is the easiest way to understand. So let's start by writing some first REST Go server, and we will try to communicate with that. So this server is basically a very simple hello world example. So let me switch the sharing to my console. All right. Do you guys see my my terminal? Do you guys hear me? Anybody? All right. Okay. So I'm going back to my terminal. So I will just copy and paste that code here. So I'll just create a main .go. All right. So I will just replace this initial code with this code that I have in the platform. So let's go through this code and see what is it doing. So if you remember from the last session, so here I start with defining my main package, and then I will import some other packages that I will need to use. The font package is the equivalent in the world of Java to system.out. So it allows to print things in and out in string to the std out, or to file, or anything that needs input output. We use the font. Log is, as the name says, it is for logging. Net HTTP here, it is used for managing the HTTP protocol and any client-server communication. And one interesting package that is really useful, and like many projects use this package, it is Gorilla Max. So this is an HTTP router. What is an HTTP router? Basically, it is a component that it is a kind of a middleware that will intercept any kind of calls and associate them to a method. So if you want to define your REST resources, you will be definitely defining some routers. And the router is it can handle some routes, which is the endpoint or the definition of the path that you want to use for your resource, and a method that will be executed when this code is invoked. So here I'm like in the line 16.
Mohamed, j'ai une petite question ici, c'est par rapport en fait aux imports de librairies. Donc là, c'est une librairie qui l'importe. En fait, il y a les premières librairies, c'est des librairies qui existent déjà dans la machine, c'est ça?
Yep. The fourth, fifth, and sixth, these are part of the language. These are part of Golang.
Ouais, et la dernière, c'est le Gorilla Max, et elle existe dans GitHub, c'est ça?
Yes. Yeah. If you go to http://github.com, Gorilla Max, you will find it in GitHub. Yes.
Ok. Donc j'ai une petite question. En fait, la dernière fois, tu m'as dit, ça serait bien en fait lorsque tu mets un projet sur Git, ton propre projet, c'est que tu fais une arborescence aussi interne qui commence par GitHub, et tu mets ton username, et après c'est c'est-à-dire le nom du projet. Alors Ça, j'ai vu que est-ce que lorsque tu crées ton projet, tu as la même arborescence, mais à partir de quel point tu fais cette arborescence-là?
À partir du github.com.
Non, mais après, dans ta machine, toi, c'est-à-dire
Dans ma
à
machine,
partir de quel folder? Par exemple, moi,
let me
j'utilise Windows. Je fais à partir de C. Je fais C, github.com, Gorilla, Max.
let me show you my configuration just to explain the things. So generally, in any machine that I use, this is a good or bad habit, but this is for what it's worth. I generally create in my root. I create a workspace, a folder.
Okay.
All right. Then in this workspace, I will put any code that I use. So this workspace is for any development that I'm doing, and inside that I create a folder called source that will contain basically my code in general. I have another folder for binaries, so it's going to be workspace/bin. And another for packages is going to be workspace/packages. And then this, if you see, I can show you my Go path. So my Go path is this workspace.
Okay.
So any code that I will put here is going to be in workspace. The code itself is going to live in source, and after this source is going to follow the GitHub.
Go is hosted in this workspace. You mean, but Go is hosted here.
Yes. Okay. So Go. So whenever I do any Go related import, export, like build and run, it will try to look at this path and try to find any package in there first. If it is not there, it'll try to get it from GitHub if it has the right path.
So here you need to settle Go. I mean, in order to work, so that you need to settle your Go path with this folder.
This is in the previous version, but in the current version you don't need to do that. So all what you need to do is to use something called Go modules. So you need to say Go mod init. And here you are kind of referring to this to your repository. So it gives this like a default value, which is github.com, the name of the folder that it hosts it, and like this path. And you can change it if you want. So when I run this command, it added this Go module. Let me show you the Go module content here. So Go module is, you can see it like the equivalent in Java is Maven. So this is the Dependency Manager. So it will basically bring any dependency that you need. So here it defined my code as a module and gave it the name of the folder, basically a simple REST, and it followed the architecture or the tree from github.com and going deep in the in this tree.
So, for example, if to put in practice, for me, for example, when I want to create, so I have my GitHub. I create my GitHub, and for all my project, what I need to do in order to refer to my own GitHub, because once I copy the project from your GitHub, I continue to use your GitHub to refer to your library. So what I want to do is to refer to my to the code that I have.
Yes. So if you want to refer to your code, so if you have your, let's say you have here, I can rename this and put it as.
First of all, what I need to do, I mean, when I create, for example, I create this folder. I create a folder called github.com with my with my username in GitHub, and the other, I mean, the remaining part of the path, it's the same as you. But where do I need to put this in my local machine, and do I need to do anything?
So if you
want Plus to recognize this as a GitHub.
So if you want to use Go modules as your dependency manager, it doesn't matter where you put it. you put it anywhere, and you only do Go modules init, like Go mod init, and it will recognize it. Then you can give it the name that you want here. So this will work in this way. And then when you update your code and push it using Git, then it will you can choose where to deploy it, like where exactly to push it to GitHub. Because this file,
to be simple, the change that I need to do is to open this go.mode to indicate this path, okay, to change this path as you mentioned, and then to execute the command to go mod init.
Yes. So you can basically execute the go mod init before modifying the change, because this is only for Go modules. This is not used by GitHub.
And where do I need to execute this go mod init? In which folder?
In the root of your code. Like if you
in GitHub, in GitHub.com. You mean?
No, in your local folder. For example, here I executed in this simple REST folder.
Ah, okay.
Okay. Does this answer your question for now?
Yeah, I will try. I will let you. I mean, this answered my question.
Yeah. So independent. Like if you are using Go modules, you don't really need to put your folder in any particular place. You can put it anywhere, then run Go mod init, and it will start using it as a module. And inside, if you wanna, for example, here I modified the path to github.com Walid simple REST. So if I need to refer to that code somewhere in my code here, if you define another package and you want to use it in your code, it's simple. You just use the name that you use it there, github.com /Walid the name.
Mohamed, la question en fait ici, en fait, j'ai compris en fait moi ce que j'ai compris, hein, lorsque tu mets ce path là, c'est qu'il regarde dans ton local folder, c'est-à-dire il regarde dans ta machine à toi.
Ouais.
Il regarde dans ta machine si le component il existe, donc il va utiliser le code associé. Sinon, il va regarder dans Git, c'est-à-dire il va regarder même ton propre Git. La question ici, lorsque je lui mets ce path-là, comment il va reconnaître, c'est-à-dire le path-là, je le mets par rapport à quoi? Par exemple, c'est un absolute path ou c'est un relative path, ça?
So it will start. So if you are in the same folder, so it is in the same project. Let's say my project here is called Simple REST, right?
Okay.
So this will be recognized from here. So it will know, like from the first line, that this is a part of the same project. Okay.
Oh, okay.
So it will get it from there. If it is not, then it will look at your local Go path. If it is there, it will use it. If it is not there, then it will go to GitHub.
Okay, so it will recognize the path thanks to this go.mode.
Yeah. This is the dependency manager basically, and you see here that it automatically went there and brought this this dependency for me, because it didn't find it here. It is not part of the same folder. It is existing in GitHub. So it went to GitHub and found the latest version, which is v1.7.4, and brought it here.
So it has been done automatically.
Yes. Yeah, if you set up your editor correctly, it will do it automatically for you.
That's it. Because I'm using thanks to Phase recommendation, I'm using Visual Studio.
Yes, let me jump to the same, because all right. So yeah, actually, let me continue then. So if you set up your editor correctly, then it will do the import for you.
Okay.
All right. So let me. So I wrote the main Go file. Now I want to run it. So it is as simple as running this Go run main Go. Okay, so now it is asking me for the authorization to allow it to be executed and open the right port. I will split my pane here just to make sure that I'm using the same. All right, live. So I am here, and this is my main.go. So here I'm using this port 877, and here I will try to do a curl just to make sure that that my code is running. This is a simple curl to localhost 877, and I'm supposed to get the hello rest, as you see here. This is what I'm getting. So just to explain this again one more time. So what I have done here, so I used this router to intercept my my call to any call that is coming to the resource / which is the root of my router. It will execute this hello handler function. And I'm using HTTP, which is the package here that I'm importing in the fourth line, which is the one that will manage the HTTP calls incoming and outgoing. So basically, I'm saying, hey, HTTP, listen on 877 and use this router. And the router is using this handle function that is associating the /, which is the root of my context, to this method, and this method is defined here. It will just take whatever. So whatever will be received here, it will just go open the writer and write a hello rest. Any questions related to that? All right, so let me jump back to the course. All right, so with that, so we have our first REST call that we did. Now I will just go ahead and try to do the same for our use case. So if you already have the code handy, you can directly check out the REST the REST branch. So this means I will just go and create everything from my side here. So I will just clone. So Walid, you can also follow my steps here if you want. I will just create everything from scratch. So I will follow these steps. So I will do a Git clone for the repo. I don't put it here in the documentation because it was done in the supposedly in the previous session. All right. Okay, so I will stop the previous code and go back one step. So here I have a simple REST. Then I will do a Git clone. For those who are not familiar with Git, so Git clone is basically copying this repository from GitHub to my local machine. So now I have a folder called shopping cart. So I will go to shopping cart and copy the same command that I have in the course, which is to check out REST. So basically, GitHub organizes the code into different branches. So if you are doing different versions of your code or different work items, you can put them in different branches, and then you can switch from one branch to another. All right. Okay, so this is if you do that, you will find the current structure of the code. So it has the main class that will be used as my main as the first code that will be executed by Go. Then it has 4 different packages. One called utils, one called server, one called resources, and one called cart. So generally, what I try to do is to split my code to these kind of known structures. So generally, people even in the open source community, you will find them putting a folder called utils that contains any useful code that you can reuse in different times. But it is not really related, like 100% related to the code itself, but it is doing some generic processing. The server part is going to contain the HTTP server. It is similar to what I shared in the first example, but it is just the main difference is that I'm splitting the responsibilities here. So I am putting the server code in the server, the handler code in the handler. I will go into the details of these. Then I have a folder called resources, and it has one file called resources.go. And also I use this structure in general. So if I'm defining any new resources that I will be using, I define them, like resources are structures here, and I will be defining them there. And for any like calls, I generally define a new resource as the input and output, or request and response value. I will also show that in a minute. Then I have my cart, which is the main component that I'm writing, and it contains the definition of my interface and the implementation of the cart that allows to add an item and delete an item and return the items and count the total cost. So let's start by looking at the main, and then I will jump to the cart and explain every one of them, and we will try to make some small changes in there. So here I'm like let's start with the imports. So I'm importing a library called context that is defined by Golang, that defines the context of where my code is running. We can use this context to pass any kind of information from one code to another. And generally, people use this also to set up like the timeouts and all the HTTP features that you can say there. I'm using the log to do logging, and then I'm referring to my own packages, which are the cart that I have here, the resources that I defined here, and the server as well. So as a first resource, generally for HTTP or for different applications, you will need to define some configuration files. Here I defined a resource. We can go and see what is a resource. So a resource here is defined only with a port. So it is a structure that contains a port. It can be more complicated than that, but for now I'm just keeping it as simple as possible. And I'm using the port 7778 for this particular application. Then I'm initiating a new cart. So basically, I'm referring to the cart package here. It is small cart.new cart. So if I go to the cart, which is the package is called cart, and the file that has the definition is called cart.go. So I should have this method called the new cart that defines how to create a cart. Basically, it is returning a cart as a type cart interface. I will go back in a minute to this as well. So here I'm creating a cart that will manage all my my executions. So if I need to add an item, I will be adding it to this cart. If I need to remove or get the total, so all the operations are related to this cart. Then I need to do, as we did in the example, in the first example, I need to create a handler. And now it is not a simple like creating the router and just handle, but since it's gonna have more resources and more paths, I'm creating a proper handler. So I'm referring to my own code here to create a new cart handler. And also I'm creating a server, and for this server, I'm passing the handler and the configuration. After creating the server, I will be just starting this server. So let's go through this code. So we will go to the cart. We will see how the handler works, then how the server works. So let's start by the cart itself. Okay. So the cart is defined as an implementation of this interface. So as we said last time, an interface describes like kind of a collection of methods that we can force people to implement in order to be in line with one API that we are describing based on our design. So for this interface, it has, for now, it has four methods. And I prefer personally, and I noticed that in some of the open source projects that I worked with, is that people prefer to describe the interface with this format. So if the method accepts any parameters, they will create only one parameter. They call it the name of the method and followed by request. So for add item, they will create a parameter called a resource called add item request, and the answer of or the value that will be returned by the add item is going to be add item response. And this is pretty useful in the long run, because if you make any change or you need to add any new attributes, you don't really need to modify the interface. The only thing that you will need to modify is to go and modify the structure. For example, here you can modify the request or the response without the need to modify the interface itself. So your interface for the long run will be really stable for your customers that will be using this interface. So same thing for the remove item. It has a remove item request and a response. Total items, since it doesn't accept any, it doesn't need any parameters. It has only the total item response, and same thing for the total cost. So my cart, the structure itself, because this is interface and this is an interface, and I need to implement it. So how I'm implementing it is using the cart structure that has simply a list of or a map of items, and I added this small kind of it is small improvement as I see it, which is the total cost. Because in order to calculate the cost, you have two options. It's either every time someone asks about the total, you go in the different items and make your calculations based on their quantity and their price, or you can optimize that a little bit, and every time you add or you remove an item, you just update your total. And if anybody asks for this total, it is just a return statement. You don't really need to do any calculations in that. All right, so I have this definition for how to create a new cart, and this is the method that I'm calling from my main. And then I have the different implementations for my methods. So the first method is add item, and you can see easily that I'm doing some logging in the beginning, and then I will start doing some if conditions just to check that I'm not in an edge case and my request is valid. So if my request is not valid, I will return an error. If the request is valid, then I will need to go ahead and I add it. So the first thing is I check if this item exists. If it doesn't exist, I will add it. If it exists, I will just modify the quantity and the price. I should be modifying the price as well. All right, then same thing for the remove item is the same thing. I will be checking the request and then checking the quantity. If the requested quantity to be removed is greater than the existing quantity, I will be doing something. If it is the other way around, I will be doing another a different processing, and this is defined here. This like the small modification that I did in the beginning will allow me to reduce the total cost to only this return thing, because already I have my total cost always calculated at any point of time. Same thing for the total items. I will be just returning the length of my items. Any questions regarding this small cart implementation? It is not like the optimal thing, but I guess it is at a good point that allows us to test at least. Okay, so I will jump to the resources here. So if you see here, I have the item is defined. We defined that last week, but the new part is the request and response. Most of the time, you can see that my response is only an error element. and my requests will basically contain the needed data to process the request. For example, in order to add an item, I need an item. And here, what you see here is small kind of JSON item. This is used in the future. We will use that in the future to do any JSON marshalling and unmarshalling. So in order to transform this request from JSON or to JSON, we will automatically this annotation will allow the automatic translation of this structure. Yeah, same thing for the remove request. It needs an item ID and a quantity and returns an error. Total items response, it will return the total items, and the total cost response, it will return a total cost and an error. So now,
la partie JSON, on n'a pas vu ça, la syntaxe la dernière fois. C'est une nouvelle syntaxe celle-là.
Yeah, it's a new thing because I still didn't use it, but it's gonna be useful. I will show you where I'm using that, where it will be useful, basically. But yeah, for now, just remember that that for the interface, I'm using these different types.
Mais si je parle de la syntaxe Go, ça c'est une nouvelle syntaxe, c'est-à-dire tout ce qui est entre guillemets en vert, c'est une syntaxe c'est une sorte d'annotation, c'est ça? Comme
yes,
on a en Java. Parce que là, on a le nom de l'attribut, plus son type, et là c'est une annotation.
It's an annotation, exactly, yeah.
Okay.
So yeah, so I will go back to this particular small annotation, but the previous part, like the name and the type, this is what we saw last time. The JSON part is the new part. I will go back to it in a second, when I talk about the handler and how it handles the queries. All right. Okay, so here I'm like in the explanation I reached this part. So we created a new cart. And now I will move on to what is this handler. So it is a handler that I gave a context and an instance of the cart that I created, which is an implementation of the cart interface. So I will jump into the code of this handler. So as you see, the handler is also kind of a structure that has different methods, and we will see each method what is it doing. So the cart handler. So we can create a new cart handler basically by giving a context and an instance of the cart interface. And this is what we are doing in the main here. We are giving it a context and a cart, which is an instance of the cart or an implementation of the cart interface. So after that, we will be kind of implementing different flavors of the methods that we have previously in the cart, but this time it is gonna be only how to process the HTTP part. So whenever we receive an HTTP query, how to make it ready to be executed by our cart, because we have an instance of the cart, and in order to add an item, we know that we already have the code to add an item. We have it already defined in the Go here, right? In the cart implementation. So we know if I give you a request, an item request, you will be able to execute this method. But the issue is that we don't really have that from HTTP standpoint. So in HTTP, there is no add item request notion. So we need a way to transform the HTTP query in something that my cart understands, right? So then my handler is defined as the follow. So it is basically a function that is defined, like inside the function, it is returning a function that will be executed every time a request arrives. So what this function is doing, basically it will instantiate an empty request. Okay, so this is how we instantiate an empty request. So it is getting an add item request here. It is empty. Then it is calling this method called utils.unmarshal data from request. So let me jump to this unmarshal data from request. So it seems like from the name, it seems like it will read the request, then it will, which is passed as the first parameter here. And it will do some unmarshalling, which can be, so in our case, it's going to be JSON unmarshalling. So it will read the request and put the data inside the item request, the add item request that we created in line 28. So how the unmarshal is working. So I defined that in my HTTP utils in this file, http utils.go. And it has basically, if you give it a request and you give it any kind of an object interface or any type of object, basically the interface here is referring to anything, it will try to read from the request body, which is in this line 90. So it will do read all the request.body. I will try to read anything in the body of this request. If any error happens, I will return it. Otherwise, I will call this method called JSON unmarshal. JSON is a package implemented by Go itself. It is part of the language, and it will try to fit the data that it was reading to the object that I sent here. So if I send an object of type add item request or response or any other type that I already defined, it will try to fit the body of the request to this object. If anything bad happens, it will return an error. If everything is correct, then it will not return any error, and it will return a nil there, and you will end up with the object being filled with the data. And here, how the unmarshalling is being done is using the annotations that we have here. So I'm sending an add item request. So let's see how this add item request is defined. So the add item request, it has an item, and it is annotated with this JSON. So if I'm using a JSON unmarshal, so it will basically try to find an item, like in the query, in the body of the query, it will try to find something that starts with item semicolon and some JSON content. So, and knowing that this is also another structure, so it will also go to the inside of the structure and try to make the mapping of the things that it is reading from the request to these values. With the ID, it will map it to the ID, and the name is going to go to the name, the price to the price, and so on and so forth. So just as a note here that this annotation is optional. So the default behavior, if I don't put these things, so it will try to find the right name. So it will try to find the closest, like ID, it will try to map it to ID, like a capital ID. The name, it will try to use the same name as the field of the structure. Does this explain your question or your concern, Walid?
Yes.
All right. All right, so we created an empty add item request. Then we passed. Notice here that we passed the address of this request. So any change that will happen to this, it will be applied to the real memory address of this item of this add item request. So whatever we get from the body of the query or the request, it will be in the add item request here. So after executing the unmarshal, I will check if I got an error or not. So if the error is not nil, it means that I got an error, and I need to do something. And since this is a server issue, I will return 500 to the writer, and I will send the response that contains the error in my writer. So if nothing bad happened, then I have a valid add item request. And now I'm ready to execute the method that I already have on the cart. And I can basically just call the method that I have. Since I have a cart and the cart has the add item method, so I will just pass in the request and see if I get any error. Same thing here. If I get an error, I will return a 500. Otherwise, I will proceed, and I can show that my cart contains some nice stuff there. Any questions so far? All right. So now, now just to recapitulate here. So I implemented. So we have the cart that implements the methods, the real methods that will be executed. I implemented a handler that if I give it, if I call the add item with a request, it will basically read the request and try to map the content of the request to an add item request instance, then call our add item method and return the answer. Now the last part that is missing is how to bind that, or how to kind of connect that with the HTTP world, because in the HTTP world I will just receive an HTTP call. So how to make this HTTP call refer to the add item, this add item method, and this is basically defined in the server.go. So in my main.go, I'm calling the server with the handler that I created, and the handler contains the cart. So you need to understand the link between these different things. So the server here, basically it has a handler and a configuration, and the new is a kind of a simple initialization of my server. And what I'm doing to initialize the handler, to start my server. So the first thing that I do, all right, so here I create the new cart. So then I initialize the handler. So here I need to, all right, so I will start, okay. So the first thing that I do when I start my server is to initialize the handler as shown in line 36, right? And initializing the handler means the first thing is creating a router, which is from Gorilla Mux that we saw in the import, and then we are trying to map this path to my method. So what this the line 28 is saying is basically saying that saying to the server and to the router, any call that is coming to my endpoint with a /v1/item and having the method type as post. So if I do an HTTP post on /v1/item, I will link this call to my handler.addItem method. And this is where the link is happening exactly. So any call that is coming to v1 item, it will be handled to the add item if it is a post. So if I try to do a get on the same one here, it's not going to work because I'm saying that only post queries should go to add item. Any questions related to this like initialization and binding? All right, so in the future, like if we want to add any new functionality, so now we have only the add item feature, and if we want to add any new thing, so we'll be basically defining what is the path that I wanna do. For example, if I want to implement a delete, so it's gonna be on the same path because they are related to the same resource, which is the item. And I will call a different method that here can be called remove item, and it will be a delete. So if I get a post, I will send it to add item. If I get a delete, I will send it to remove item. So I will try to do this. For example, here I need to go to the handler. I can basically copy this code in order to do the remove item. Okay, so I will implement, so it has a receiver as the cart handler, so then I will do remove item. So it is basically getting the reader and the writer, and I will be logging here to say that I'm in remove and I'm exiting remove. If you remember here, the defer says that after executing the method, just execute this command after the execution is ended. So I will do the same thing for the remove. So instead of initiating a resources.add item request, so I will be doing a remove item request. So here I'm doing an item. Let me rename it to remove item request. then I will try to unmarshal this request and put the request that is coming into my my object that I already created. If I get an error, then I need to raise it and say that I have an issue, and I need to return the right type here. So it should be remove. All right. So after that, so now after succeeding this call, like after doing the unmarshalling, I am here with a remove item request. So I have a remove item request, and I can call the remove item method that is defined in the cart itself. So I have the remove item here that is that accepts a request, and it will return a remove item response. So I'll just execute it. And if anything bad happens, so I will be testing on the error. If anything bad happens, I will return a 500. Otherwise, I need to write the response to my writer. Any questions here? All right. So until now we have implemented the add and remove, and we can also continue to implement all the other methods. But I already published the code to GitHub, so I will not go into like all the details. I want to move to the next part of it. So let's first try to execute this and see how it goes. All right. So I'm splitting here. All right, I'm going to my shopping cart. Then I need to do go run main.go. All right, so if everything is good, it will start there, and I should be able to do a curl to create my my first item. So I prepared the query. It is a simple curl here. So I'm doing a post. I'm doing a post here to my local host with 7778 /v1/item, which is what I defined here. Remember that I defined here that any query that is coming to v1 item as a post method, I need to call the add item code. So let's see, and I'm sending a JSON value since I have the marshalling set up to use JSON, and in the JSON I'm sending this data that contains an item that is defined as this follows like the resources that I defined here. So if you look at my resource, you need to see the first thing that you need to see is an item. So here I have an item here. And then you need to find like the content or the value of this should be relevant and should respect the item description that is here in my resources as well. All right.
Mohamed, si on n'a pas mis la notation JSON, celle-là, avec item, un small I, normalement, on doit, si on met pas la notation JSON, hein,
we can. I will try.
I, ça marche ou pas?
Ça doit marcher. All right. So
normalement, pour lui, est-ce que c'est single column ou double comma? Les séparations, c'est quoi?
This one,
data. How to structure data? By default, it's JSON or
it's JSON? Yeah. It depends. No, it depends on the code that you wrote. Because here in my, if you remember in my
the marshalling, it depends on the marshalling.
Yes, exactly. Because in my HTTP utils, I use it JSON and Marshall, right? You remember that?
Okay.
If I use it something else, if it is YAML or TOML or any kind of other like XML or something else, I need to respect whatever type I used here. Otherwise, it's going to show an issue.
Mm-hmm.
So you see here that it is a JSON, and I'm specifying also in the content that this is a JSON. So after sending this, I didn't get any error here. And if you see here, like my log, it was showing what are the steps that I had. So it entered the add item. this is in the handler layer. Then it went to add item in the cart layer, added a new item, then exited this functionality, then exited the add item in the handler layer again. So you see kind of the trace of what was executed. All right. So any questions so far? So if you want to see the latest version that I put here, you can just git check out. I think it was called RESTful. I will add everything, git stash this, then git checkout. All right. So in the RESTful, this is the full version of the code. So you can see that I did kind of a small change to the interface. I added get items in order to be able to test, and whenever I add an item, I should be able to just to see the result of adding that item. But other than that, if you look at the handler or the server, it is almost the same. Like if you take a look at total cost, you don't even need to do any marshalling because you don't have a parameter coming, but you need only to write back you need to execute the method and return back the result. Same for get items.
Mohamed, si tu peux, s'il te plaît, lorsque on utilise ton Git, tu mets dans la plateforme WebEx, comment ça s'appelle, le site web, oui, WeThink, tu mets les commandes qu'on doit faire. En fait, on fait un fetch. Tu mets l'ensemble des commandes qu'on doit faire et à la limite, si tu peux rappeler en fait les changements qu'on doit faire dans le go.mode.
Oui.
Tu fais une seule fois ça, parce qu'en fait, là, on va partir d'une branche à une autre. Donc, nous, on a juste besoin de cloner ton produit.
Yes, après... exactly. And I already have that in the platform, Walid. I have I have that in the platform. Let me show you. All right, let me share.
Tu dis quel changement on doit faire pour le go.mode ou pas?
So in order to make it run, you don't really need to make any change. Unless if you want to make changes like to use your own features. But
ça, en fait, le changement que je veux faire, c'est pour ne pas se reporter à chaque fois à ton Git. Parce que jusqu'à maintenant, moi, je l'ai téléchargé et je l'exécute, ça marche très parfaitement. Mais je constate, c'est que j'utilise les librairies de ton Git. J'utilise pas mes propres librairies. C'est-à-dire, je n'utilise pas les librairies qui sont en local dans ma machine.
Okay, I can add that. I can easily add that and just make sure to replace my my Git repo with your with anybody else ID, and they can be integrated easily. Just make sure that if you do that, then every time you do this kind of import, you need to import yours, not mine.
Yes.
So if I, let's say I will just go here and replace it with Walid, okay? So if I go here, I need to be referring to Walid instead of my own.
On n'est pas en train de voir le.
Oh, sorry. Yeah, let me share my. All right. Okay. How about now? So I went in the Go mode. I used your name here, and now I'm making like the changes to just here. I specified Walid everywhere, right? And I will go to the server instead of mine. I will use yours. Same thing in the
tu dois changer aussi l'arborescence de tes fichiers, non?
No. If you are using Go mode, doesn't matter. You don't really need to do that because it starts by, as I told you, it starts by looking locally. So if you define your folder as Walid, then here it will start seeing this inside your folder first.
Mais ici, en fait, ici, t'as pas fait un folder qui s'appelle Walid chez toi, donc ça va pas marcher.
Yeah, because it is looking at this as the module Walid.
Ah, donc il regarde en fait ça, il regarde tout ça comme le local pour lui, c'est ça?
Yep.
Il n'a pas besoin de voir qu'il y a un folder qui s'appelle comme ça chez lui.
Yeah, it will start by the local folder. Otherwise, it will look at the go path. Otherwise, it will go to GitHub.
Ok. Donc en fait, le chemin là, Walid, c'est juste pour indiquer my username name dans le go path. De toute façon, lui, il regarde que localement dès le départ.
Yep.
Mais c'est-à-dire maintenant, lorsque moi je l'utilise actuellement sans que je change, il regarde de toute façon, il va regarder les librairies qui sont en local. Il ne va pas regarder le Git.
It starts by looking locally. If it doesn't find anything locally, it will jump to the remote thing. You see, I just did the changes and it works. If anything bad happened, it will raise an issue here.
Oui. Même et ce Git n'existe pas parce que moi, j'ai pas un username Walid, d'accord? Okay.
Yeah. It doesn't matter. Yeah, it doesn't matter.
Parce qu'en fait, il va récupérer les serveurs et les handlers qui sont ici, en fait, les resources. Il va récupérer ce qu'il trouve ici, en local.
Yep. It starts by looking locally. If it doesn't find anything locally, it looks at GoPath. If it doesn't find anything in GoPath, it will jump to GitHub. If it doesn't find anything in GitHub, it will throw an error.
Ok, right? Ok, super, merci.
All right. All right. So I'm on the same part. Okay. So I'm starting to run the same code again and just doing a curl one more time. Then I will do a curl to get the content and see if it was added. It should be, but we never know. All right. So I will do get items. Would not resolve host. Okay. For some reason. Okay. Oh, yeah. So I should not do get like that. All right. So items it not recognized here. So let me check what is the code that I'm running. All right. Okay. So I need to be looking at v1 cart items. So if I add cart /items, okay. So now since I created two items, pepper with two quantities, 1 and 1. So then the total quantity is 2, and my code is up and running. Any questions until now? All right. So yeah. So feel free to clone the repo and check out the different branches and try to run it locally. And if you have any issues, just let me know, and I can try to help if I can. Okay. So going back to the course, and let's see where we are. So we did all of that. So we were able to do the get and add items. So all of that is running fine. So here I'm putting that if you are done, or if you want to check the real code, it is on the RESTful branch. So just do a git checkout, and you should be able to see the latest code. Yeah. So next is the quiz. Please take a look and try to take on this. All right. So a small bonus that I like to share with you also is this Swagger project. So Swagger is basically the ancestor of the Open API specification, which is kind of a standard that allows to define APIs and allows a clear description of your API. So if you want to work on a project, the best idea during your design is starting by describing the APIs of the different components. So if you have a component, just define the interface or the API, how this component will talk to others. What are the inputs? What are the outputs? What is the data model? So this is very important to have, and Swagger allows to do that in a very nice, fancy way, and very useful to generate code and keep your code really organized and keep everyone on the same page. So let's jump ahead directly. Swagger, they have many tools. Some of the tools that you can use in order to build your API is either a Swagger editor. So if you look at, if you try to Google Swagger editor, you will find like the first link is the Swagger editor, and you will find an example of an API. It's not going to be the same as mine because it's caching my own definition. Also, there is a Swagger Hub thing that you can use for, this is like the Swagger editor is a temporary thing. You can use it just for small demos. But if you are in a big project and you want to keep your API description and your collaborations, you need people to join and make changes, and you want to do different iterations on that, I suggest to use Swagger Hub. Which is like GitHub, but it is for API descriptions. So personally, I created this one just for the purpose of this course, where you can describe your API and probably test it if you want. And you can also, the nice thing is you get the nice documentation here that will reflect your API, and also you can generate code. So for example, if you see my screen here, I can generate different types of servers. For example, I can automatically generate a Go server for my code. So all the parts that I wrote previously, most of them will be generated automatically. I need only to write the business aspect of it, like anything that is specific to my code, I need to write it later. But this gives me like a good step ahead in order to generate and be in line with different teams. They should be in line in how to write the code and how to implement things. So this is a good starter point for any team. Also, you can generate clients. You can generate a Go client. You can generate you can see like different types of clients that you can do. Also, you can generate your documentation. It is a very strong way of sharing documentation between teams. I saw like many people using Swagger as their documentation, because you end up describing how your component is going to work and what are the APIs and the models that you will be using. Yeah, so I encourage everyone to go there and start from there if you are starting on any new project. And also you can save different versions. So if you write the first version, you can save it, then collaborate and create a new version out of it and generate the code, and it will kind of keep the track of your changes. So just as an example, you can hit on this link and you will find yourself in my shopping cart API, where you can describe the API that we were talking about, which allows to add an item, remove an item from a cart. So the same content that you see here, I already have it in Docker Hub. So just let's quickly go through that, just to show you how to make the changes in order to add a function, for example. So for here, like I start the description of my Swagger by the different information about my project. For example, this is a shopping cart, and this is my version. This consumes and produces JSON. As we discussed previously, and then I will start describing my paths. So these are the REST paths that we had in our code. So I can say that for v1/item, so if I get a post on this, how can I process it? So for a post call, I will call the add item method, and I should return a 200, for example. I can have multiple responses. For example, if I have an issue is going to be 500, for example, I can do this, for example, and I can say I need to describe this. So this is a server error, for example, and I can specify what is the schema or the object that I need to return. Of course, I need to define this in the same file. So, for example, here, if I let's put the same thing here, and it will be it should be happy now. So okay, so should be an object. All right, so this is definitions / add item response. All right, so yeah, so it should be in the so I need to refer basically to this definition in my file. So definitions here, it is referring to my file. Also, I can add new paths. For example, if I want to do the same thing that we have for the cart items, I can do this, and I can say that this is a get. For any get, I need to do an operation ID, for example, that I call get items. And here I can specify that the responses, for example, for a 200 response, what should I do? So description is gonna be successful call and list of items, and what is gonna have as a schema. So it should return a list or an array of items, as we described that. So I can do here, it's gonna be, all right, so ref here, it should be in definitions. I need to define that. So definitions, and so the response for this one is get items response. All right, of mapping entry. Okay, so here it is complaining about the.
Ici tu as mis carte, non, c'est pas à la limite tu as mis carte ici et en bas t'as pas mis carte. Tu vois.
Which.
Dans la ligne 11, tu as mis carte et lorsque tu fais V1 item, tu mets pas carte.
Yeah, because I wanted to be in line with what I had in the code, but to be consistent, indeed, it should be /v1 / items. All right, so it is complaining about the indentation here because it needs to be a valid YAML thing. And here I need to define the get items response. So get items response. So as it's saying here, it should be in this definitions section. So if I go here, I will find this definition section. So in the definition section, I'm basically defining all the things that I'm using. So if you see here, So if you see here that I'm defining the add item response as an object, and it has as a property, it has this reference to item. And item is defined here as an object. Also, it has an ID, a name, a price, and a quantity. So if I want to correct what I have there, so I need to have get items response, which is a type. Should be an object. I think it should be an array. All right, so let me check really quick. Yep. So so it is an object, and in the properties here, so it has items. So I need a list of items, which the type here is an array, and I need for an array, I need to specify basically what is the type of the items of this array, and I can refer to internal definitions like this one, for example.
Il n'y a pas d'éditeur plus sympa. Tu dois faire comme ça.
So this is the most, like, the best one. This is the best. It is like, if you get used to it, it is very helpful. So I can, the other editor is this Swagger editor. Basically, it's bigger, you see, and I can use the same thing. You see, it starts showing you errors directly. So if I have an issue here in my path, and it is complaining about it. So.
Parce qu'il y a beaucoup de choses qui se répètent en fait. Tu dois pour que les paths et après tu fais un get et après tu fais des opérations en fait.
Yes, yeah. Generally, there are other tools to generate this for you. It can allow the generation of this, but like for a starting point, it's is pretty like if you get used to it, then it will be like copy paste. For example, for the post, I already need to copy some stuff and put it here. It's not really a big deal. But when you get used to it, because you need to take care of all the details of your API, and once you are there, for example, here I have a better version. Don't say because it's bad. For example, I have a better version of my API. I can take it from there and post it here, and you see like the nice documentation that you have. So you know directly you can explain this to anybody that you have for a cart. You have these different methods. You have a get method that will return this example of result. For items, it will return an array of items, and each item should look like this. Same thing for a post. You need to send an item. The query should look like this, and the response should look like this, for example. This is pretty useful as a documentation. So you can use whatever you prefer, like this Swagger editor or the Swagger hub, but this is more useful for teams to collaborate on. But once you get used to it, it becomes really straightforward to do, since it is just a simple YAML, and YAML has this this particular kind of issue of indentation, because you need to take care of that at all the time. So yeah, so once you have that, then you can basically generate a Go server, for example. So I have my this is my API. It has all these features, and it is using the different models. You have also the description of the models that you have. For example, add item response is defined this way. It is close to what we wrote in Go. But this one, supposedly, you will start with the API, and it will generate that for you without the need from your side to write that in Go, but it will write it for you. Okay, so just to generate that, you can go here. So it will generate a zip, and let me just switch and show you really quickly the thing before jumping to the containerization. All right, so I downloaded. Okay, let me close this, and all right. So I downloaded that. So I will copy or I will move from my downloads the Go server to here. Oh, yeah. Okay, so let me Vim and show you. So it has a main, which is gonna be somehow close to what we did, but it is doing less functional stuff. So it is creating a router as we did before, and also it is doing a listen and serve, which is similar to what we did. And inside the API, you have the YAML thing, and also you have the model, which is close to the resources that we described previously. For example, the item, it is exactly what we did as in our resources. And in the routers, you can see that they are using Gorilla Mux and also attaching the different routes. So for the get, if you get a get, and on a particular index, so this is like really linking the different methods. So if you get the an add item, you will, and it is a post, you will call the add item method. And if you go to the add item, it is basically an empty HTTP code. So it is not doing anything. And if you want to do that, you need here to do the unmarshalling that we did previously in our handler and call the cart that you have. But this is really like a good starting point for you that handles every aspect of the modeling and design of your code. Any questions regarding that? All right. So yeah. So this is I think this is kind of a good starter for people if they want to use Swagger to describe their APIs and generate code. But I will stop here unless if anybody has any question regarding this. Otherwise, I will jump to the next section. All right, so one last thing here is if you guys are interested, there is a way to generate the Swagger itself and to generate lots of code, but also it is a new way that Google is doing a huge efforts in to replace REST, which is using gRPC. Why using gRPC instead of REST? Because gRPC is so much faster. I believe the last time it is like 16 times faster than REST. So if you are interested, I put a link to a blog post that I wrote some time ago. So it is basically how to start from your API description using gRPC, and how to generate all the code and the documentation and how to run it in a Docker container. So feel free to take a look at that, and if you have any questions, also feel free to reach out to me.
gRPC n'utilise plus HTTP, c'est ça? Il utilise RPC directement?
No, gRPC is basically called HTTP2. It is using HTTP.
Ah, d'accord, mais c'est pourquoi plus rapide alors?
Because the structuring, the marshalling and marshalling is so much faster. And also it is using HTTP2 instead of HTTP1. But when I say HTTP1, because REST is using HTTP1 and gRPC is using HTTP2, and it will take care of all the marshalling for you, which is so much optimized and it is so much faster as well.
Et c'est les mêmes méthodes, en fait, on utilise les mêmes méthodes, get, put.
No.
Ah,
no, actually, yeah, you will be using a client. You can, if you want, you can expose a REST interface, but this is not the way that people are using it. You end up having a client that will do the calling. This is why you are kind of gaining like in terms of performance in the client side and in the server side, because both of them are optimized to use the structures that gRPC is defining, and they are using the same protocols.
D'accord. Et toute l'histoire et tout ce qui est Swagger et tout ça, il y a des choses qui ressemblent à Swagger ou il n'y a pas?
There is no way to do it. So if you look at here, for example, the description of the APIs, it is called protobuf. So you can use protobuf to describe your API. For example, here it is really close to Go, but it's not exactly the same. For example, here it is describing your request, for example, and your response. And then you need to define your RPCs. For example, here the create object, imagine like the create item, it's going to be defined as an RPC here, and you need to define it as an interface. And you can say that it accepts a request and returns a response. And then there are tools to generate the code for you with the right structures that will do the thing. Here, this small part is for the to describe basically how your HTTP endpoint will look like. So it is /v1//object, and this part is optional because this is adding another layer of REST on top of that, but this is completely optional.
Tu n'as même pas besoin de spécifier tes endpoints.
You don't need that because you are specifying the RPC, and when you generate the code, it will generate the stub and skeleton from both sides, like for the client and the server, and you will be using the methods that are generated. So you will have a create object method that is implemented from the client side, and a create object that is implemented from the server side, and it will do the mapping for you. All what you need to do.
Mais ici, tu es lié, à la fois tu crées le serveur et le client, parce qu'en fait, tu utilises l'approche orientée service et que ton client, il peut être indépendant du serveur. Tu l'écris dans n'importe quel langage. Ici, par exemple, on a créé un serveur en Go, on aurait pu créer le client en Java, tandis qu'ici, c'est pas le cas.
No. It is the case because this protobuf is independent of the language itself. Then you can generate the server in Go. You can generate the client in Python.
Ah, ça c'est indépendamment du langage. Ça. Ah,
yes,
d'accord.
It is independent. It doesn't. Just my example was in Go, but protobuf and Grpc is independent of Go, and it is not any way related to Go. You can use it in any other language. It is a big project led by Google, so they have like different implementations in different languages.
Et c'est très utilisé maintenant ou pas beaucoup?
So just to give you an example, like Kubernetes, all of it, all the interfaces, all the things are using gRPC. Cloud Foundry, it is almost like everything is written in, like all the APIs are defined using gRPC.
D'accord.
All right, so let's move on. This is like for me, this is one of the most exciting parts, which is Dockerizing our code, because like in this new era, like people do not use virtual machines or physical machines anymore, or almost anymore. In any time, if you wanna run any new code, the way to do it, the first thing to think about is how to put it in a container. Why a container, and what is a container? So basically, let's go through the history first. So what is Docker? So Docker is a tool that allows people to put their code or their applications in a particular container. And this container contains like all the needed packages and dependencies to make this code run. So you can say that, oh, this is similar to virtual machine. You can put all your code in a virtual machine and make it run. But the only difference is that that virtual machine is using a hypervisor, but a container can run directly without the hypervisor, and it is so much faster and so much lighter than a virtual machine, because you end up producing lots of dependencies that you don't really need in a container, but you still need in a virtual machine. So here there is a small kind of comparison between VMs and containers, and like the advantages of or the I would say the criteria of a VM is heavyweight, because you need all the mechanics to run on top of a hypervisor. A container in the other side can be very lightweight. The performance is limited, and since you don't have the hypervisor in the container side, so the performance is so much faster. All right, what else? There are many advantages of using containers. The only drawback compared to VMs is the security. That is also something that people are working on. So virtual machine is more secure than a container, because the level of isolation given by a hypervisor is so much powerful than what is given for containers right now. Even though there are lots of research being done to improve the isolation of containers, and there are some new directions to run what they call micro VMs, or very lightweight VMs, that are very close to a container in terms of performance and speed, but they are still secure. So this is an effort being done by different companies trying to take the lead on that, like Amazon and Google. Yeah, so if you want to read more, there are lots of documentation comparing VMs and containers. So I would suppose that you are convinced that containers are the way to go. And let's see. So I don't know if you guys went through this course and prepared for it and installed Docker. Because if you didn't do that, you will not be able to follow the next steps. So if you already did, this is fine. If you didn't, please go ahead, try to find how to install Docker and set it up for the right operating system. For example, for me, if you are using Linux, you can find your distribution for Windows or for Mac as well. You can install it, follow the right configuration. There is a small post configuration that will allow you to, if you are on Linux, for sure, there is a small post install steps that you need to do in order to be able to execute the binary without sudo, which is the super user kind of prefix in order to be able to execute these commands. So in order to know that your setup is correct, you can run this hello world container, which is basically just a container. If your setup is correct, it should say hello from Docker and some other nonsense stuff that you can use. So any questions? Did anybody have any trouble installing Docker? Any blockers here? All right, so I will let me just switch. So you can keep your browser here. So what I will be doing is I will try to create a first container that runs the code that I did for the first hello rest that we did, and then I will move on to to containerize our application. So let me switch the sharing one more time. All right. So all right. So here. All right. So let me start by running the Docker run hello world. So if it doesn't find it, it will try to pull it. Otherwise, it will just execute it. And here you see that I got the hello from Docker. So I have the image. And how Docker runs exactly? It is using kind of Docker images, which are a way or kind of a structure that describes how this container is built. So I will describe exactly the different steps of building a Docker image and how to use it and reuse it and publish it and share it with people. All right. So let's go to the simple REST. So I have this simple REST code. All right, simple. All right. I have the main.go. So it is the same that I pasted on the platform. So I have a simple go. So if I run it, it should be, I can be able to execute it here. HTTP on 8777 should say hello REST. Okay, all right, this works. Then I need to be able to create a Docker file. So everything in Docker is based on Docker files. So for any project that you want to containerize, you need to start by creating a Docker file. So I will create a Docker file, and all right, so this is my Docker file. I will paste in the content that I have in the platform, so, and explain what does this mean. So basically, any Docker file starts with this line, which is from, that specifies an image, a source image that you will start building your container out of. So here I'm saying that since my application is Go, I will say that I will start building an image from Golang, which is the main image in Docker Hub. So if you look, yes, I didn't define Docker Hub for you, but it is like it is similar to GitHub, but for Docker images. So if you are working with Docker, you need somewhere to specify or to register or to store your images, and that is there is the public one is called Docker Hub, and there are many other private ones. Google has their own. Amazon, they have their own. Like every big company has a registry or a hub for storing their images. You can also run your private registry. So this one is saying that go to Docker Hub and get the Golang image. So we will start from this image. Then we will create or use this specific location to put our code. So this work dir is basically specifying that this is my work directory. Whatever I will be doing is going to happen in this particular location. First thing, I will be putting everything there. So I will copy my main.go and my Go modules. Then I will run this line, which is I will execute exactly this code. So go get is basically going to download any requirements that I have, any dependencies that I need. It will just go and do it. And then there is this go build. The go build is basically building a binary out of my code. So if I run this, for example, let me try to run it locally first. So if I do go build on my main.go, is gonna, and I can specify, for example, I wanna call it hello, for example, like my binary is gonna be named hello. So it will basically generate a hello here, which is a binary that I can execute this way. So it is similar to executing my code. If I try to test it, yeah, it is responding here doing the hello. All right. So back to my Docker file. So I will be building my main.go, and I will call it app. And then I will say that my container will use this command to start. So if I am trying to run this container, it should execute this binary in order to start. So do you guys have any question regarding this? All right. So basically, I'm trying.
Elle fait quoi la ligne 6? Go get -d -v.
So this is basically downloading the dependencies. This can be done in different ways. So we can do that if we are using Go modules. We can do Go mod download, or we can do this that will kind of try to download any dependency that it doesn't have locally. It is just a different way of downloading the dependencies that we need. So after downloading these dependencies, I will be able to build my binary, and then I will tell the Docker runtime that if you want to run this image, you need to execute this binary. This is all what you need to do. So in practice,
la ligne 4 qui fait copie, elle fait quoi copie dans répertoire courant?
So it is basically copying everything from my local folder, which are main.go, go.sum, go.mod, and the Docker file, and it will copy it to the work dir inside the container. So it is copying files from my machine to the container image.
Mm-hmm.
All right. So in order to use this file, I can easily, so what I can do, so here, let me go back to the same folder. So being in the same folder, I can run some Docker commands. So there is this command called Docker PS. It will show you if you already have any running containers. If you don't, it will just return an empty array like this use case. If you want to build an image, you can do Docker build, and you specify, if you are in the same repo, you can just do Docker build and dot, but you need to specify so I think this will work as it is, but if you want it to be useful, you need to give it a name. So for example, for me, I generally use my GitHub, my Docker Hub and GitHub ID. in order to build my images. For example, if I want to share this with someone else in the future, I need to respect the Docker Hub structure that I have. For example, if I want to share this with you, I need to use my ID and the name of, let's call it simple live rest, for example. I need to just to give it a tag. So this, what is this doing? Oh, build. Okay, so it is saying that this should not be capital letters, so I can do this. So what I did here is I said use the Docker file in this repo, which is in this folder, which is referred to by the dot, and build me an image based on this Docker file and call it or tag it with this tag. So now it will start executing the different commands that I have in the Docker file. So you see here that the first one it is doing from Golang. So it is using the image Golang, and it is referring to that with a commit, because every step here is going to be saved as a layer in my file system, for building the image. After that, it will execute the line 3, which is using this. Also, it's going to be referred to with a commit, and it's going to be a different layer. Then it will execute line 4, line 6, 7, and 9. So every step is a new layer. After it is being done, like completing all the steps, it will save this and tag it with this tag. So now I have this Docker image. So what I can do with this Docker image? So I can execute it, and it will replace my my old code when I was doing go run main.go. So now I can do, for example, Docker run, and I can specify this. And I need to specify, though, I need to specify the ports that will be used. And so this application is using the port 8777 internally, but if I don't expose this port is going to be only recognized inside the container. So there is a way for me to expose this also to to my machine, to my local host, which is by mapping this port to any port. I can choose any port that is not used in my machine, for example 8888. And choose the port that is inside the container. So the second part, the 8777, should match the port that I'm using in my description, in my code itself, which is here. And the second part matches any port, or the first part, which is the 8888, should match any port that is open in my machine that I want to use. Let's see. All right. So file not found. No. Okay, so now I'm kind of trying to find the issue here. All right, so I think that I need to do the Docker run this way, or I can put any port here. Let's say this one, and then use my image. All right, so it seems to work now. So let's try to execute. So if I try to target the port that is defined in my code, which is 8777, I should not see anything because this port is not known in my machine. Instead, I should use the one that I specified in my port here or here, which is 8888. So if I do this, it should respond. All right, so I see the hello rest here. Any questions so far?
You got a question from Lami on the chat, Mohammed.
Oh, sorry, I was not checking my chat so far. So, all right, so so there are two questions there. So let me respond to the second question really quick because it is straightforward. We can consider that GitHub is Docker Hub. We can consider that so GitHub is meant for code. Docker Hub is meant for Docker images. So let me show you really quick the difference between the two. All right, so you see my screen. So I will go, so GitHub, you already know GitHub, so I will not explain what GitHub is, but let me go to Docker Hub. So if you go to Docker Hub and create an account, I already have an account, so I will not redo that. So you can enter in and search for any images, and you can see repositories and see, it is like, it has a similar structure as GitHub, but all what you see there, you can go, for example, for the shopping cart, I have Docker image. So it looks like a repo, but if you go there, what you will find how to, like, the information about this this image, the different tags that I used, when was the last time that I pushed this this image, and so on and so forth, and how I can download and use this this image. I can add more description, but since this is just only for me to test with, I didn't put like lots of descriptions here. But this is basically like GitHub, but for Docker images. So for example, if I go back to my repo, so I don't have any. Let's create a new image, for example. So the one that I created here with this simple live, I can push it and it will show up there. So what I built here is a new Docker image. So if I do Docker images, it will show up all the images that I have, and if I do grep here on the live one, so it will show this image with this size, and when was it built? It was built 7 minutes ago. Now I can do a Docker.
On va pas, Mohamed. On va pas.
Oh, sorry. All right. So can I share all the desktop?
You can just say like Docker Hub is kind of virtual appliances in the case of virtual machines and the hypervisors, right? If you can make the parallel with
yeah. So for virtual machines, you can have a similar kind of registry for your virtual machines, but it doesn't work exactly like Docker images. They have a different architecture and a different layering mechanism, and it is all based on the Docker file.
From concept point of view, I understand that the implementations and the architecture could be different, but from concept point of view, it's I mean, let's say kind of.
Yeah. The closest thing is it is a registry. It is basically a catalog, or you can see it as such. For this is like the equivalent for VMs. It would be that. But yeah, it is a common place where people can share their content or their Docker images. So if you build an image, and for example, if Walid or Sami now want to use my my own image, so what I can do is I can do a Docker push, and let's use the same. All right, so okay, so. So what is the image that all right, so this is the image that I created. Now I want to push this one to Docker Hub, so anybody else can reuse it. So I can do this. So now it is like taking the same layers that I have locally and publishing them to the Docker Hub. So now if anybody of you wants to reuse this one, he can simply go to and do a Docker run in this way, and it should work in this exactly the same way. So if Walid, if you want to do this, or anybody else, if you want to use this one. So do you see my my browser here by any chance?
Yes.
Yes.
All right. Yeah. So you see that I just published this this image. And so it was updated a few seconds ago, and anybody can go there, copy this command, and start using it without even modifying the code. It will work in the same way. So if you run it and do a curl this way in your local host, it will just work. You don't really need to understand what it is. You don't need to make any changes. So if you need to make changes, then you need to go through the same steps that I did, which are doing the Docker build and then the Docker push. So this change will be propagated to others to reuse. Does this answer your second question? So the push command will put the image, the Docker image, in Docker Hub, not in GitHub. So yeah, so the idea why we want to make the objective, what is the objective of making Docker if we will push it in GitHub? So the code will live always in GitHub, but the executable or the thing that is running, because the image here, for example, let's imagine this is what I was doing here is very simple use case. But imagine that you have a system like, I don't know, MySQL database. You don't really want to download the code for MySQL and try to make it run with like any changes. You want just to have an easy way to run MySQL in my machine. So what can I do in order to do that? I need to go to Docker Hub, try to find MySQL, and see there is a MySQL image. I can go there. I can do a Docker pull, Docker run, and I have a MySQL running in my machine. No need to know the code, no need to understand anything, no need to know which language is it being used with or any implementation details. All what you need is MySQL up and running. You just go and get it and it will work. Same thing, like there are many, let's say, if you want to do MongoDB, just try to find it in Docker Hub. There are different flavors of MongoDB, and you can reuse them. Same thing for your code if you want people to be able to reuse your code, because imagine that you are working in a team and every person is working on a different aspect of the code or probably a different component. So everyone doesn't need to understand every details of the others. All what I need is give me the Docker container. I will just run it and write my code to talk to it. I don't really need to understand. I don't need to install Go. I don't need to do anything of that. All what I need is just to run it. So this is how it is done. Build a Docker image, publish it to a GitHub or to a Docker Hub or a repo where people will be able to pull it from, or a registry where people will be able to pull it from and run it. This is how it is done. So for the first question, which is, can you resume the steps for general use, not with Golang? Same thing. So it is like the same strategy. So for example, let's say we want to write code for Java. So the change that will happen is instead of starting from a Golang image, we will start from Java with a particular configuration. Then we will put our code in the same image and do some compilation and we'll make sure how to run our code. So we'll basically describe how to get our code in a state that will be runnable. So I will try to find in here like Java Docker image, Docker. Or Docker example.
Docker file example.
All right, so okay. This is a code, so they write a hello code. Okay, so you see here what they are doing. This is their Docker file. So they are starting with this OpenJDK image. So this should, so if you try to find this, you will find it here. In Docker Hub, there is OpenJDK. Definitely, there is OpenJDK Alpine, OpenJDK. There are different versions of OpenJDK, and they are referring to that particular one. So you can have different flavors, different versions. So if you want to use 6, 7, 8, or 9, or whatever, you can specify that as the tag. Then you you start describing how to make your code run. Then this is like you can specify environment variables. You can copy your content. For example, here they are using a jar file, so they are copying it. You can copy Java code or Python code if you want to use a Python image. It's gonna follow the same principles. You will start from an image that has the needed mechanism to run your code. You will put your code, copy it using the copy thing. Then you, at some point, you will need to specify how to execute your code. For example, this is for Java. They are saying how to execute the code. You will do java -jar/app.jar. So you will specify this jar file. If it is Python, you will start from a Python image. Then you will add your scripts, your Python scripts. And as the entry point, you will run, let's say, Python 3 and give the file name as a parameter. But it is all the same, the same steps that you can follow here. Does this answer your question?
The concept's still the same, Lamia. I mean, the methodology and the concept's still the same, independently of the language you choose. Muhammad did choose Golang because he likes Go, but he could do the same steps with Java or any other language.
Yep. Yeah, it's independent of the language, but you know, you need always to choose the right image to start with, and go from there. And like the same steps that you do to run your code, you will basically need to describe them like step by step in the Docker file in order to be able to run the code.
L'autre chose intéressante aussi du moment que tu as l'image sur le Docker Hub, c'est que tu peux réutiliser cette image-là pour construire une nouvelle image.
Yes, you can refer to it. So if I want to build another image, I can start from this one, for example. I can put here that I need to start from this image and do new stuff. Like if I need to add more things, I can add new things there.
Par exemple, pour ajouter un client ici qui utilise ce service, un client, je sais pas, un client Go.
So yeah, but I think what you want to do generally, like how to split your code, is very important in choosing what to put in the Docker image, because you don't want to put two things that have different functionalities. For example, for me, it is not really that useful to put the client and the server in the same container, because they have two different functionalities. So you will end up having two containers if you want to run them separately. You need to have two containers, one for the server and one for the client, and make them communicate in one way or another. We will see like this splitting in the next session, but this is the way to do it. Generally, try to have one container per functionality, unless if you have really compelling reason to do otherwise. Any more questions? Let me take a look at the chat. Okay. So all right. So I wanted to reach the point where we do the Docker example for our own use case. So I will go to the shopping cart and do the similar thing. If you see my screen here, so I showed how I push this thing. So I can just copy this content to build our Docker file. So I will do. I will create a new Docker file here, and I will just paste the thing. So let me explain this really quick, which will have a different way of like downloading the dependencies than the previous one, and we can enhance this in the future as well. So this is starting for the same image from Golang, creating a directory, then like making it the running directory from which I will be using everything. then I will start by copying my dependencies, which is, if you remember, it is defined in the Go mod, and it is locked in this Go sum as well. And then I will do a Go mod download. In the previous example, I did the Go get, but in this example, it is a different version, and it is using Go mod to download. After downloading all the dependencies, I will copy all my code inside the container. Then I will do something very similar to what I did before, but it's just with more flags. But the most important part is the Go build. It will build a binary called shopping cart from my main.go file. And after that, it will say that if I want to run this Docker image, I need to execute this binary. Any questions regarding this one? So if you look at it, it's very close to the previous one, but it is starting from the same image. But instead of downloading the dependencies using Go get, it is using Go mod downloads. After that, it is the normal copy and like copying my code inside the container and then doing the build and then saying that whatever I build is going to be used as my entry point to execute the thing. So I can do a Docker. I will just copy from here just to make sure that I didn't make anything. So I can do Docker build the shopping cart. All right. No, it's not. All right. Copy. Paste. All right. So it's Docker build -t shopping cart and the dot. Okay, so for some reason it's frozen. Okay, let me open a new one. Okay, so I will just build a shopping cart. I need to, I didn't name the Docker file the right way, so I need to Docker file. All right, so now it is building my image. So it is basically following the steps that I created from Golang, making the directory, then copying the Go mode and Go sum, downloading the dependencies, and here running the Go build. And after that, it is saying that this will work with the, this is my entry point. Finally, I can do a Docker run for this one. And okay, so I use it. Okay, so I can copy the same thing. So I use it 778 as my port. I will use the same here, and I will use the same image that was built here. All right, so we see that the cart was created, and I can do a curl on 778. So items is empty. I can do a post. So it is basically repeating what I did before. I created an item here, another item. You see the output here is showing that that things are getting through. If I do items again, I get that 3 items were added to my to my cart, and everything works. And you don't really need the code. If I do if now I do this, like if I do a push now, you can reuse the same image without any change in the code. So if you do a Docker run in the same way that I did it, it will just start running in your machine, and you can start doing curl commands locally in your machine as well.
Mohamed,
so the main...
J'ai une petite question ici. Lorsque tu fais le push, c'est à quel moment qu'il fait, en fait, lorsque tu as créé l'image, tu fais pas le lien entre les, tu fais pas le lien entre les ports. Et là, lorsque tu fais le push, c'est à quel moment qu'il fait le lien entre le port utilisé dans le Docker et le port utilisé par la machine?
In the run, when I do the Docker run. So in the definition of the image, in the Docker image, you can say that this image exposing this port, but always in the Docker run, when I do Docker run here, I specify in the -p here is it means the port. So bind this port. This is the port that is used inside the container.
Ah, c'est-à-dire plus tard, par exemple, lorsque moi je veux faire c'est-à-dire là tu as fait ton push toi. Et moi, je vais utiliser ton image à partir de Docker Hub. C'est à ce moment-là que je dois spécifier le port. C'est ça?
Yes, yes. And the first part of this this flag, like this one, you can change it to any port that is open in your machine. So I can use this one. But the second part, you cannot change it because this maps to the port being used by the container. So I can do the same thing here, and I need to, instead of going to 7778, I can do 8989. Otherwise, it's not going to work. So it is giving me the answer, basically.
Ouais, l'association entre les ports, elle se fait toujours plus tard. Après.
Yes, so if you are using Docker, it's going to happen when you run your Docker container. If you are using, in the future, we will see how to use Docker Compose and Kubernetes, and we will show how to make the port mapping. But it is always during the run when you make the mapping of the different ports that you are exposing inside the container to the ports that you want to use in the host.
Mohamed, juste une question. Le port 7778 dans le container pour l'application, il est spécifié quelque part dans l'application?
So it is. Let me share that. All right. So this is my code. So here I'm not doing anything specific to say anything about the code, the port, but I can be more specific to say expose and put the port 8777 here. But this is like implicit because in my code here I'm specifying the port here. So I'm using the port as in the code itself.
Ok. Thank you.
Mais lorsque je charge toi ton image à partir de Docker Hub. Si tu ne me donnes pas cette information-là, je ne peux pas le savoir.
You cannot know it. This is why I need to either to put some documentation in my image. So let me go back to my repo. Okay, so I have the shopping cart. I have the tools to modify this description and put whatever I want here to describe how to use my container. And this is generally what people do. Like if you go to, and let's say I want to use OpenGDK, right? So if you go there, you will find so much better description than mine. You will find a complete documentation on how to use it, an example, how to build it, how to run it, and also if there are any requirements about the port, I need to specify it there. But this is just for our example here. Since we wrote this code together, I was supposing that the port is already known. And there are some other Docker containers that they have a known port. For example, if you are talking about Elasticsearch, it is known that it will automatically fall back to 9200. If you are talking about I don't know. Like there are some known applications that require a particular port. Sometimes they don't specify that because it is a known thing. But yeah, definitely I should describe that somewhere in the documentation to let you know that this is the port that is exposed. It's either in the Docker file itself and or in the documentation.
Donc dans le Docker file, je peux faire la commande qui fait le mapping entre le port de...
No, you cannot make the mapping. You can say that this container exposes this port.
You cannot, or it's not recommended? No,
you cannot. You cannot make the mapping in the Docker file.
Because you cannot run the Docker image from there.
Because yeah, so the Docker file, it is to describe how to build the image and what is the entry point, how to execute the things. But it doesn't describe anything related to the external environment where the code will be running at. Because when you specify, when you do the Docker run, this is where you exactly specify the different things that link the container to the outside world. So here I can modify, like when I do the Docker run, then I can specify to which port the internal port will map in my host. But I cannot do it in the Docker file. Any other questions? I think we are running out of time. Like the next step that I wanted to share with you is what we call a multiple or a multi-stage Docker build, which is a kind of an optimization. Probably we will talk about that the next time because it requires like few more minutes to talk, but it is a way to reduce the size of the image and to optimize how to run it and how much time does it take to pull it. Because if you try to pull my Docker image right now, it's gonna be like the size of that image is gonna be about 900 megabytes, which is huge. And using this small step of optimization, it will take it from 900 megabytes to 8 megabytes, which is very important to reduce the time of pulling and starting the image. So I will talk about that. I will start the next session with that, and the next session will also talk about how to use multiple images or multiple Docker containers if you have a distributed application. So let me stop the recording right here.